Okay, so let's get started. As mentioned before, we are going to start with data access. You had a homework until today. Last week we started with the case study. I have opened the case study here, and your homework was to come up with an entity framework core data model implementation for these requirements. The homework wasn't easy, I mentioned it before. It's a non-trivial data model. In practical terms, it's still not that complicated. But for this school, for this course, it was one of the more complicated data models that you have probably ever designed, at least when using an object relational mapper. And therefore, I would like to give you a few tips that might be relevant whenever you design something like that. For the Matura and the exams, the data models will probably be a little bit smaller, but still you will very likely need many of the aspects that I'm going to show to you today. You can find the sample solution in our GitHub repository. As you can see here in the homeworks folder, I created a folder 0200 data access, and here you can find the relevant projects. What I would like to do is I would like to get started by setting up a brand new project environment. So I'm going to start a new solution to show you how I'm going to get started. But after a few classes that we will create, we will switch to the ready-made project because it doesn't make sense to type everything in. I just want to demonstrate how to get started, and then we do a code walkthrough, and I will just talk about the code that I have prepared, okay? So, does it make sense to follow along on your computers? I don't think so. I think for this first part, it's more relevant if you follow, if you make notes, if you ask questions, and if you make sure that you understand the concepts, okay? You have the code, you have the solution, so it's no need to write down the code. In the second part, after this entity framework core stuff, we will switch gears and go to the front end. We will talk about Angular, and then it absolutely makes sense to follow along, okay? I will tell you when we come to that. So let me quickly create a new folder here on my computer in which I'm going to work. Let's call it EFCore Share for Future. And here we are. Good. This is my empty folder, and I'm going to work here in this folder. Let's spin up Visual Studio. And let's create a solution for that. Good. Here we are, latest preview of Visual Studio 2022. You know that already, and we are going to create a project. It was part of the requirements of this homework to get started with a web API project. So let's do that. Here we are. Nothing special here. I called it, how did I call it? Share for future dot, nothing dot, just share for future. Oops, I selected the wrong folder. I want to have it in this folder here. Here we are. Now it's good. .NET 6, we don't need OpenAPI for this project. Let's create it. Now the first thing that we could do, we could immediately start to implement our data layer inside the API project. In a real-world project, I will probably not do that because you might have a web API, you might have some Blazor front end, you might have a command line front end, you might have multiple user interfaces for the same data access layer. So in this lesson, I would like to go one step further and create a shared library with the data access code. Just to demonstrate how this is done. It's really simple if you use C# and .NET 6. All you have to do is you have to create a new project. It will be a class library. Let's call it share for future.data. Of course, .NET 6, obviously. And in this share for future data, we are going to put our entire data model, the data context, and so on. And that allows us, let me install my Zoom tool, sorry I didn't start it before. that allows us to build multiple UIs. Here we are going to have the API, but you could create a WPF app, a MAUI app, a command line app, and they can all use the same data access layer. Get the idea? That is why in many cases you extract the whole data or the whole data related stuff into a separate class library. And I'm going to show you how this is done. In the Web API project, we can clean up a bit. We don't need the generated weather forecast. We don't need this controller stuff. And the rest is okay. It's okay. We don't need to do anything more. Now we need to add a bunch of NuGet packages. Let's do that. Manage NuGet packages. And by now, you should know by heart which NuGet packages we need. Just look for framework. And then you can look for first the NuGet package reflecting your selected database. So if you choose SQLite, use SQLite. If you use SQL Server, and this is what we are going to do, choose SQL Server. And we are going to install it here in the share for future.data. Okay? Good. Install this guy. Good. It will take a few moments until we have installed it. Good, done. Next one, we need the design package. Who knows, who can remember why we need the Microsoft Entity Framework design package? Last time we talked about object relational mapping, and there was one aspect that we talked about where we need this design package for. Yes?
Sure, to create the
To generate the migrations, perfectly correct. If you want to generate the migrations and you don't want to write it by hand, and this is definitely what you want, then use the Microsoft Entity Framework Core design package. Let's put it into the share for future data. And last but not least, if you create the class library for your data access and you want to generate the database from your class library, we need to read the app-settings.json file. Normally, the app-settings.json file with the database connection string is in the API project. But now we are in the, let's use another color, we are in the data project and there is no app-settings.json. There is no infrastructure for reading JSON files. Understand what I mean? So we need to add another NuGet package. And this NuGet package can be found by looking for configuration. And then we should see Microsoft extensions configuration JSON, here you have it, because we want to add an app settings JSON file. Easy to remember. You don't need to write that down, it's part of the GitHub repository. If you want to build a class library with an entity framework data model, you probably want to do that. Understood? Good. It will only take a few seconds, and then we have it. Nice. Good. Now we can copy the app settings JSON to the class library. We just need one, and we are good. We can add the connection string. You can look up the connection string in my GitHub repository. I think you should already know how that works. I will not go into the details here. Nice. So the first thing that I do when I create an entity framework data model, of course, I take a look at the requirements, and I typically start by modeling the classes that reflect the requirements in my case study. So let's start with the first one, and after the general description, we see the users here, right? Let's go for the users first, and let's design the user entity. So therefore, I'm going to create a separate class here. I will call it users, but this is just a file. So I will immediately remove this class because we will add additional classes here. Now there is a nice little feature in C#10 which comes in very handy. Instead of putting all your classes inside of a namespace and always having these curly braces around it, in C#10 we can make it a little bit easier to read. We can move the namespace declaration up, and simply add a semicolon at the end, and then we don't need anything else. That will automatically tell C# that the entire file should be inside of that namespace. It makes your code a little bit easier to read, one indentation level less. So this is something brand new in .NET 6, in C# 10. It's completely optional. If you like it, now you know it, use it. If you don't like it, ignore it. I'm perfectly fine. If you want to do the indentation and the curly braces, it's completely up to you. Good. Let's create the class user, make it public. No question about that. And then we will simply add the necessary code. And do you see another goodness of Visual Studio 2022? It immediately recognizes my typical coding pattern. It sees that I create a class user, and when I create a class user, it suggests, hey Rainer, do you want to add an ID? Because this is what you typically do, and this is what people typically do. I just press tab, done. Isn't that beautiful? I really like it. Now the next thing, we need, for instance, a first name, prop, string, first name, nothing special. And we need maybe, oh, you see, Visual Studio 2022 immediately recognized that if you have a first name, you probably have a last name too. Tab, we are done. This is AI-powered coding. This is what you can get used to. This is the future of your business life. Your IDEs will get more intelligent and more intelligent and more intelligent. In the past, and you already have a past, you have 4 years in the school, you used to look up data and logic and things in My Material, in Stack Overflow, and so on. But the future looks like that. We have artificial intelligence robots, sensors built into our IDE, and these things are smart. They are not super smart yet, but they are okay-ish. Good. We can now add multiple of these things, but it doesn't pay off if I type that in manually. So I will just use this these 3 dots, and we will take a look in the code walkthrough later on. For now, it's okay. We get a warning that first name is currently doesn't have a default value. Let's say the default value is string.empty. That's fine. And here the string.empty should also be the default value. Did you see? Equal sign immediately suggested. Nice. I like that. That is good. I need to add one additional property, prop, string. Let's call it contact email address. And let's also make it string empty, just so I can show you one additional aspect of building this data model. In real life, you now go through all the different requirements and model the user class accordingly. You would add town and street and zip code and blah, blah, blah. We will leave that. I have done that in the sample solution. Now, we need to add additional metadata. We need to say how long the first name should be, how long the last name should be. We need to create a unique index here on the contact email address, and we can do all these things in 2 different ways. At least one you should already remember. That is, here, something like max length. Can you remember? We had that last year over and over again. Data annotations was the magic word. We could do that, but today I want to do something different. Let me get rid of all these usings here. I want to show you how we can configure that with the Fluent API, because as you will see, in a more complex data model, the Fluent API is the way you should go because it gives you a lot more freedom. And this is the real world. This is no longer, I don't know, childish playground. This is now more real worldish, let's call it this way. So what we can do when we create the data context, let's do that. Let's add the share for future DB context, for instance. Let's make it public. Can you remember? Here, semicolon, move it up, and get rid of the curly braces. I definitely like that one more, but as I said, it's completely up to you. So let's take a look at this share for future data. Ah, see, Visual Studio is smart. Now we have the DB context. We need a using statement here. And now we can override some things. And we have this on modal creating where we have this modal builder. Modal builder. And here we can, for instance, say entity of user. That would be one of the first ones. And now we can define various things. For instance, we can say has key. And we can say this should be the user ID. This, what I just entered here, is the same as here specifying key. Got it? And if I want to have a max length, I could say modal builder entity user. Whoops. Come on. Dot property. First name. Dot has max length 100. See it? That is the same as writing max length 100. Do you get the idea? Now the question is, what do you like more? Do you like this Fluent API more, or do you like the annotations more? I really don't care. You can choose. In practice, more people prefer the Fluent API if you are dealing with a larger data model. Why? Because this larger data model gives you way more, or the Fluent API gives you way more control over all the fine-grained details. So for instance, we can add a unique index. We can define the relations between the different entities with the Fluent API. So this is the powerful tool. The annotations are for very simple use cases. So for beginners, the annotations are perfectly fine. In more complex scenarios, you need a mix, or, because many people dislike mixing two technologies, they go for Fluent API all the way. Because then you have the entire configuration in a single spot. Understood? We have a question, please.
So you can mix it?
You can definitely mix it, but I would not recommend that. I personally would go for one technology if possible. If I have a very simple application, I would probably go for the data annotations. If I build a prototype, for instance, where I don't really care about the details and I don't care about all the special things in my data model that I would like to tweak, then I quickly go for data annotations. But if I really want to think about every single aspect of my data model and I want to carefully think about the table names, property names, and so on, then I typically go for the Fluent API. But that's just me. If you want to do it differently, feel free, have fun. Okay? Good. Now, that is definitely possible, what you see here, but the problem is that this method will be pretty long. Because we have users, we have tags, we have offerings, we have sharing, we have many different relations. So building all this in a single method like on-modal creating is probably an overkill. Therefore, Entity Framework has the capability of separating these modal creating stuff into different classes. So you do that like that. Let me show you that. I think it's easier if I show it to you, okay? You simply create a second class. Let's call it user entity type configuration. And then you have to implement a certain interface. This interface is called iEntityType configuration of user. This is part of Microsoft Entity Framework Core. And this allows you to implement the public void configure entity type builder of user. Hey, come on. I said entity type builder. Sometimes the IntelliSense is not as smart as it should be. Let's call it builder. And then you need one additional using, this one. And now I can add with builder dot, for instance, key has key, user goes to user.id, I can add all the modal configuration in this class. So we now have the user and the modal configuration directly side by side. Do you get the idea? It's nicely separated. It belongs together. It still is in one place. I personally like that. Got the idea? Now the question is, what do we have to do in our modal creating? Somehow we have to make it clear to Entity Framework that we have all these different entity type configuration classes. And it turns out that this is really, really simple. What you can do is you can say modal builder dot apply configuration from assembly. Assembly is just a DLL. So what I can do is I can complete that one, and now Entity Framework will automatically, without me doing anything, look for all classes that implement entity type configuration and will look for the Fluent API in the configure method in all these classes. So this is all we have to do, just one line, and it will look up everything else automatically. So your data model over time can grow. You can have dozens, hundreds of classes, and you always have a nice combination of the data structure in C#, the class model, and the type definitions which are related to your storage engine. Understood? In really large projects, you might even consider more complicated structures, but this is reasonably okay for mid-sized database development projects. Did you understand the combination? Is that fine? Do you see the advantage when you do it like that? I hope you do. Okay, very good, very good. So now we have this entity type configuration. We have defined one key. Let's also say we need the property u goes to u.firstName, for instance, and make it max length here, max length with 100, for instance. Okay, that looks probably okay-ish. Good, I'm happy with that. So let's add a dbSet property. You already know that. dbSet of user. Let's call it users. And here we just say dbSet of user, and that's it. Now we have our dbSet. Everything is good. What else do we need? What is the last thing that we need in order for our database context to work? You could look it up in the cheat sheet from last year or in C# documentation. It's the constructor. We need a constructor, this one, and this constructor gets the DB context options of this one. Let's call it options, and we have to call the base class options. So we have to make sure that Entity Framework gets its options, for instance, the connection string. This is the only thing that we have to do. Our dbSets, our constructor, on modal creating, and yeah, that's it. Got it? Nice. With that, we can simply try to create our migrations for the first time. Should we try it? I tell you, it will fail. Okay, so don't be disappointed if it will fail now. So let's go into share for future. Where are we? I'm in the wrong package. I'm in the package manager console. I didn't want to go into package manager console. I wanted to go into the terminal. Much better.
Control would be the shortcut.
Yes, I tried it, but for a reason that I don't know, this shortcut brought me to the package manager console on this laptop. I'm used to my shortcuts on my desktop machine, but this is wrongly configured. I don't know why. So let's go into, let's check it quickly. I have to go one up and share for future.data, and here we are. Now we are in the right set, you see. This looks good. Let me zoom in a little bit so you can see it better. Now I hope you can see it. So .NET EF migrations add in it something like this. Let's go for it. It should fail. Boom. See? Your startup project doesn't reference Microsoft Entity Framework Design. This package is, let's check that one. Let's go here. Microsoft Entity Framework Design. It's already here. Okay, I think I just didn't save the files. This was not the error that I was expecting. Let's try it again. I was expecting a different error. I think, now good. So the entity framework tooling is older than the latest runtime. Who can help me solve this problem? What is the problem here? Yes?
You need to update your .NET tools.
Exactly, I need to update my .NET tools. So let's do that immediately. I don't know how to do that by heart, so I will quickly go to last year's HTML, C#, I think it was like that, right? Yes. So, oops, wrong one. Last year I gave you this nice little cheat sheet, and here at the top I told you that you can, with .NET tool update -- global, you can update this guy. So let's do that. Let's copy it here. And version should be this one. Let's give it a try. Was successfully updated. Good. Retry. Maybe I will now get the error that I was looking for. Oh yes, this is exactly what I was looking for. Sometimes you are happy about an error. This time I am. Now you see, unable to create an object of type share for future DB context. The difference pattern supported at runtime are blah blah blah. Can anybody tell me what the reason for this strange error is? I now have the referenced NuGet packages fixed. I have the correct entity framework tooling installed on my machine. So everything should run smoothly. We can also check whether the database context is public. Yes, it is. Do we have an app settings JSON file? Yes, we have it. And for generating the migrations, we don't need a connection string in it. That's fine. Do you have an idea?
I don't remember, but did we put in the program.cs, did we tell it that we need a DB context?
Okay. You have a very good idea. What you say, we are missing here in program.cs the addition of a reference to the database context and adding it to dependency injection. You are partly correct. You are correct, we are missing that. But for the moment, I don't want to do that. Because I want to just use the class library as a standalone solution. I don't want it to be necessary to add the data context to the dependency injection system. And that's the problem. You see, the entity framework tools, they are, exactly as you said, looking for the database context that you add in your program.cs. But we have a class library. Do we have a program.cs in a class library? No. Exactly. So how can we solve that? Answer, we need a so-called data context factory. And last time, here, in your material from last year, I added you exactly that. So if you have a class library, that should be your entity framework project, you have to add such a context factory. Because then the entity framework tools will look for the factory and use it to discover your database context. Understood? This is only necessary if you want to use a separate class library. Got it? Good. Nice. So let's do that. Let's put it here. We simply have to rename, so let's not call it blogging context factory, but let's call it share for future DB context, something like this. And then let's replace.
Mark the context, now you have context twice.
Now I have context twice. You are right. So Let's redo it. 1, 2, 3, 4, 5, 6. Good. Let's see. I'm missing a using statement here, obviously. Good. And the configuration builder. Good. And we don't need that logging stuff. And I think we are good, right? Let's give it a try. Let's build this guy. And let's retry adding the migrations. Build started, build succeeded, and we get a lot of errors here. Let's see. Oh yes, I finally forgot the connection string, because now we finally really need it. And I have it also here in my cheat sheet. You can use the cheat sheet from last year. It's still perfectly valid. Let's call it share for future DB, something like this. Good. Rerun it. Maybe we will now be able to solve it. And finally, you see, we got the migrations. So it was a lot of things to do in order to make the database, the entity framework stuff work in a class library. But do you see the value? Now we have a class library. And we can use it in a command line tool, in a full client GUI. We can use it in an API project. We can use it in an ASP.NET Core Razor Pages project, wherever we want. That's really nice. We can put it on NuGet.org in order to make it available to the world, because maybe somebody else wants to use our class library too, maybe our colleagues. Understood? Is that relevant for your exam or your Matura? No, because there we only will build one single project. But still, I want to teach you more than just what you need for your Matura. This is practical stuff. This is how it is done in mid-sized database projects in the real world. Okay? Good. Happy with that one. Now, what is the reason why we really need these configuration things here? Why do we really need the Fluent API? Now, the Fluent API is really relevant for things that we can't do or can't easily do using data annotations. For instance, we want to have, and that's part of the requirements, we want to have a unique index on contact email address. And this is really trivial if we do it in a Fluent API. You just look for index, has index, and you say, hey, give me an index on the contact email address and make it unique. Single liner works perfectly well, and that will do all the create unique index thing in SQL that you might need. Understood? That's really, really nice. To make it more clear, we will add, and that will be the last thing that we do here in this project, we will add the user group. Public class user group. The user group also has an ID. Nothing special here. Let's give it for demo purposes a name. And we want to have a collection. Can we have multiple users inside of a user group, or can we have a single user in a user group? Multiple. So we go for a prop, make it a list of user, and call it users, right? On the other hand, here in the user entity, we have, as defined in our requirements, a single user group per user. I simplified that compared to a real-world project. So let's go for the user group and call it user group. Make it optional, because during a query, you might want to load the user group, but sometimes you don't use the include clause to load the user group. So therefore, whenever you do a relation, make it optional. And finally, we will add the user group ID to have the foreign key available. Got it? And now comes the important part. And that's the last thing, what we do now before we go into the break. Now I can use another entity type configuration. This time it's the user group. The user group. The user group. group. Entity type configuration. ID is the same. The name is okay. Max length. By the way, I forgot to give it a default value, and I also forgot to give this one a default value. It's fine. And now we can use the Fluent API to specify the relationship. Has one, I'm mistyping these things. User group with many, let's call it G for user group, users. Then I can specify has foreign key, group ID. This is the foreign key. And last but not least, I can say on delete, what should happen if the user deletes a user group? Should all the user in this user group automatically be deleted too? If I would want that, I would choose cascade, but I don't want that. So therefore, I say delete behavior restrict. And that means if a user group is deleted, the users should still be there. Understood? And I can also say that this is required or not required. In this case, I say it's not required because there should be users without a user group. So this is a perfect definition of a relationship between two entities in our entity framework model. You see, you have control over all the different property names, as you can see it here. You can specify the delete behavior. You can specify whether it is required or not. It gives you much more control than by just using a bunch of data annotations. Understand what I mean? And this is what you need in a reasonably complex data model. Do you get the idea? So let's give that a try. Let's remove the migrations and regenerate them. Here we are. Let's run it again. I'll zoom in so you can properly see it. And see, it worked. And .NET EF script, I think it's output migrate SQL. I think it is like that. I hope I could remember it from the top of my head. Nope. I forgot the migrations, sorry. Good. And now if we take a look at the generated SQL statement, here it is. Now we have the user group, looks good, the users, looks good, and here you see the foreign key. See it? User group, the delete no action is here, just as we want to have it. And here you see that the user group ID, in this case, is properly inserted. Got it? And also the unique index is here. So this is exactly what we wanted. Right? Good. And I immediately know what it is. I'm sorry, I made a mistake. Obviously here, see? If the foreign key is nullable, it can't store a null value in this foreign key, and that was my mistake. I'm sorry. Thank you for pointing that out. Let's quickly generate it for the last time so that you will see that it really works. And then we'll do a break, okay? Generate the migration script, and now I'm pretty sure that it should work. Here is it. And drum roll, here it is. See? My mistake, my fault. Thank you for pointing that out. Okay, thank you very much. We will do a break until 11:55, a little bit more than 5 minutes. And then we will switch into the prepared solution and do a code walkthrough of the entire model, okay? Good. Enjoy the break.